So following on from being able to read a network, the next thing we're going to look at is the shortest path, which is the shortest path between two vertices in a network is the path where the sum of the weights of the edges is the smallest. So it's basically going all the way around and finding which is the shortest way to get there. So how to find it? Redraw the network with circles at each vertex. So we've got that here with the circles. Calculate the shortest distance from the start to each vertex, one edge from the start. Write the distance in the open circle. Calculate the shortest distance from the start to each vertex, two edges from the start. Write the distance in the open circle and continue until finished. So we need to find the shortest path to get from A down to C, okay? And these distances are shown in kilometers. So you can do what the steps are at the top there, or you can just go through each of the different ways, and you might do that several times to find that shortest path. So if we do that, we can say, okay, I'm going to go A to B, which is 6. I'm going to go B to D, which is 4. And then I'm going to go D to C, which is 7. So if I'm looking at that one, that gives me a total of 17. Okay, so that's this way here. All right, so next one, I might look at, well, I went with 6. Let's go with 2 here. So I've gone A to E, which is 2. So this would now be then following what it's saying. So you're looking for that shortest distance. Okay, so from E, I've got 3 and I've got 8. So the shortest one would be to B. So we'd go E to B, which is 3. From B, I can only come down. I don't want to go back up to A. So I would go B to D, which is 4. And then I would go D to C, which is 7. And so that one is going to give me a total of 16. So we can see that one's already better than the first one I did. Okay, we still need to check all the other options to make sure that is the shortest path. Okay, so from here I could go A to B, which is 6. I could go B to E, which is 3. Then I could go E to D, which is 8. And then D to C, which is 7. That gives me a total of 24. So we know that one's definitely out. And there's one more we can try. So we can go A to B, which is 6. B, oh, sorry, I mixed that up. We want to go A to E, which is 2. E to D, which is 8. And then D to C, which is 7. And that gives me 17 as well. So we just need to check all of them, okay? You can see that using the method above where we're looking at, well, which is the shortest path, the shortest edge from each vertice got us to that shortest path. That will work most of the time, but if you want to double check, you can go through. Depends how big the network is. If it is a really large network, you would be following that rule and going through and saying, well, which is the shortest to each of those next nodes. Okay, so all we had to do there is find the shortest path, and we can say that is in kilometers.